Welcome to Wearable Ant Farms workshop number 1. We're going to learn all about LED sensing. So people may have seen yesterday, we were chatting a little bit about what your LEDs don't just shoot light out, but can also sense light coming in. Wow, that's bonkers. Amazing. Well, we're going to learn how do you actually do that today. And the way that we're going to do it is playing around a lot. And so first, like the right way to do, light sensing, probably with an Arduino, if you look up like Google, like Arduino light sensor, you're going to have like these little gizmos that got legs coming out and then some squigglies on the top. Those are usually, they're photoresistors. And they're basically a resistor that changes its amount of resistance depending on how much light shoots at the photoresistor. You can hook this up to another regular resistor and make a voltage divider, and then you're able to monitor how much light is coming in by that change in voltage read by the Arduino. But look at this. It's got wires everywhere, you got resistors, you got LEDs over here, you got some squiggly things over there. Psh, look at this is easier. This barely even makes sense. Okay, so the very first thing I want you to do is you're gonna take your Arduino and you're gonna shove LEDs in one side. The other side's even just hanging out. That's what I mean, like this really shouldn't probably work at all, but somehow it kind of does. So your LED, it has, so everybody has an Arduino and some LEDs, right? Cool. You can probably unmute yourself. You're the main folks I'm chatting with here.
Okay.
Nice. Cool. So you have an Arduino, you have some LEDs. Your LEDs have one long leg and one short leg, right? The long leg is the positive leg that you plug into positive things if you want it to turn on. So for instance, if you plug in your Arduino right now, you'll see on one part of your Arduino, you have some things that say like 5 volts and ground, GND right there, right? If you take your Arduino and you plug the long leg, let's say plug it into the one that says 3.3 volts and the other one that says GND, you'll see it turns on, right? Here, I'm gonna plug it in. So this isn't any code or anything, that's just electricity. So that's just turning your LED on. This is what LEDs are supposed to do, okay? So you can try that out. This is how you just turn on an LED. What I want you to do is, I want you to take that short leg. This is the negative leg. Normally it just goes to ground, but since we're reversing everything here, we're gonna make it a sensor pin. So your short leg is gonna be the sensor pin, and I want you to plug it straight into A0. A0 right there. And the other pin, you don't even have to plug it into anything. This is how freaky we're gonna get with the LEDs right now. Just let it dangling out. Normally for any kind of electronics, this isn't really what you wanna do. Usually everything's plugged in somewhere, but we're just gonna leave it out for the time being because we're gonna be playing around with it. And you can take LEDs and put them in those first, let's say at least those first 3. So A0, A1, and A2, and just shove the short leg into them. And whenever you have these janky ass LEDs just kind of hanging out of your Arduino, I need you to get the workshop code. We're gonna have 3 sets of Arduino code that you can access from that chat link that I just sent. If you go to tinyurl.com/PIFcamp you can also find it. I just made 3 sketches that we're going to use in this workshop today. And you just need to download all of them and then open up the one that says 0, just sticking in LEDs. Okay?
Okay.
I just make it as straightforward as possible.
It's gonna take a bit.
Yeah, exactly. So shove your LEDs in, get your workshop code loaded up, and then let me know when you all are ready for the next step.
All right.
So these are like, this isn't, every time you make an electrical circuit, everyone tells you like, oh, hey, you need to make a complete circuit. These things are just sticking in there halfway. It's craziness. But if you put some lights on it, and you'll actually see like, at least for me, they get all wiggly and they get fatter wiggles, right? You have skinnier wiggles and then fatter wiggles, the more light or the less light that you have. And so what's happening is, like I was saying before, normally your LEDs, you can put electricity through them and then it basically shoots photons out. But if you shoot photons at your LED, it actually makes like kind of a very small electrical current. And even though it's not plugged into anything, what it's doing is it's kind of charging up the LED and having like a very slight voltage on it. So it's kind of charging up, but it's still very messy. That data is not very good. They're not very responsive. And after a while, they get less and less responsive because that charge kind of builds up and the LEDs don't really have anywhere for this electricity to go. So if you are ready for the very next, very simple step, what you can do is you can take one of your LEDs, let's say the one that's plugged into A0, and you could plug the long leg into ground, and the short leg you keep in A0. And this should make it a much better sensor, hopefully.
Close to the ground.
Yeah. So now if you see on mine, I have just these two LEDs, one still dangling out like before, and then one is plugged in like you just plugged yours in. If I move it in front of the light now that I have over here, you're gonna see a much bigger difference in my chart. See that? That's like this big blue line shooting up. That's the LED that's plugged into the ground. So it's much more sensitive now and reacting much more the way a light sensor should work. So bright, not bright, bright, not bright. And so that's helping out your electrical circuit now because we're making it a little less stupid. And now when that electricity that's generated from the light shooting down onto your LED, it has somewhere to go and it's able to kind of measure itself a little bit better. You're able to kind of like discharge it a little bit and have it keep going. So now you should have a much better light sensor made out of just that LED. But we can get even better whenever we're ready for the next step. But so you can see, even just right now, if you took the light sensor that you have hooked up, so it's just an LED, the short leg stuck in the sensor pin, the long leg stuck in ground. If you put a light on one side and your LED on the other side, you have a pretty decent sensor you could wave your hand in front of. You could put them on each side of like a tube and let, you know, a gerbil run through it or something like that. Probably not sensitive enough still for an ant, but that's okay. We're gonna figure out how to make these even more sensitive. So the next thing is try out different colors of LEDs and see how they respond. And you can even shine other colors of light at different LEDs and see how they respond. So you have some of those UV LEDs, you can see how they work. In theory, the LEDs are most sensitive to light from the same color as them. So a red LED will be most sensitive to red light. Okay. Green LED will be most sensitive to green light. But in reality, it seems like the red LEDs, the longer lights, have a broader sensitivity. So a red can also sense like green or even blue, but a blue LED has a much narrow range of sensitivity. So like it can only sense blue or ultraviolet kind of things. Because the way that LEDs work is they have this special substance in them that whenever electricity goes through it, it basically drops some of the electrons in the atoms to a different charge state. And this drop makes it have to release a tiny bit of energy, and it releases that energy as light. And because each atom has a specific, like the way that its electrons are arranged, it'll emit a very specific color of light because of the gaps that basically it has to drop down. And so they first invented red LEDs because that was kind of the easiest. But then it took them longer to invent other color LEDs because they had to figure out the right different types of substances that would release this exact color of light. And so then when it happens in reverse, you have one specific color of light going down and exciting this substance and making the electrons actually move up a level and generating a little bit of electricity out in the circuit. And you can put like a blue one next to a red one and then test them out at the same time. Now I think you're ready for the next step where we try to make it a little bit smarter. So what you're gonna do is we're gonna make it a little bit better. What we're gonna do is we're gonna make an LED gate. And so we're going to plug 2 LEDs in, and we're gonna have them, they're gonna be able to like calibrate each other and set up kind of a modulated light sensing. So they'll be able to tell whenever something goes anywhere in between them, and be able to sense hopefully a lot more effectively. So what you need to do is you take one of your LEDs and you're gonna take the short pin and you put it in A0 like you did before, and the long pin, I want you to put it in A2, okay? And you're gonna take a second LED and you're gonna put the long pin in A3 and the short pin in A5. And you can see them just like in this image that I have up on the screen.
The second one doesn't light up, but maybe it's...
That's fine. That's exactly, yeah. It should not be lighting up yet.
Well, the first one is...
That's fine, yep. Yeah, it should look like this.
Yeah.
Right now.
Yeah.
Cool. So now you need to go to workshop code 1 and load up this new workshop code. It should have the moving average library removed from it, but if not, just re-download it again. They're lit up?
Yeah.
Cool. Okay, they should both be lit up, right?
Yeah.
And if you go to the serial plotter, you should be able to see 2 lines for them. And then if you put something in between them, you should hopefully be able to kind of notice it. Or if you wave your hand kind of over it. You should see nice, much sharper spikes.
Yeah.
Wow.
Okay, so
Cool.
this is an ant.
Yeah, exactly. So that's the idea. That's an ant. It goes through. It totally can sense it. One other thing you might notice, if you see my lines on my computer, you see how they're still like pretty wavy right now?
Yeah.
So a lot of that is actually noise from my laptop being plugged in. If I unplug my laptop, that noise, it comes from like the walls basically, gets removed. So if you're just running on battery power, you can actually get smoother data sometimes. But it's not bothering it too much, but just FYI, sometimes the wall power messes with your readings. And so, yeah, so now what's happening here is I've slowed down my LEDs a little bit so you can see them. But what it's doing is you see how yours, they're probably blinking really fast and just kind of look like they're on. But they're actually alternating, turning on and off. And if you wiggle it around, you can actually kind of see them. Like if you swing it back and forth, you can see how they're turning one on and then the other on. And so what's happening is one turns on and shines its light, and then the other turns into a sensor. and senses how much light is being shined at it. And then the other one turns off, and then the next one turns on and becomes a light, and then it shines and makes it into a sensor, and it's measuring how much light is coming at it. And then they both turn off, and they measure how much ambient light is around. So this one is a little more robust, because even if I start pointing it outside or a cloud comes over or something like that, it doesn't change the values as much, because it's looking for what's the difference between what I'm just seeing in the world in general and something that's much closer to my LEDs, and something that's actually being affected by the light shooting out of one LED and bouncing into the other LED. So this is how we can get a much more modulated light sensor input with our LEDs like that. Cool. And so you can play around with that. You can do things like if you plug two jumper cables into one side, and so that you can have the LED, one LED facing the other LED, that's where you'll get the most sensitivity and probably the biggest response, because it'll be shining at it. And these types of LEDs, they're most sensitive coming right from the front.
Okay.
So you light coming right in there. They're not as sensitive from the sides. So you attach an LED to some jumper wires or to a breadboard that's connected with jumper wires and then point it at it, it'll work even better for you. And so now I have like a sticking my tongue out detector. And so all those little blips, that is basically what we're looking for when we want to do any kind of ant detecting. So the goal is, so then like, for instance, you know, the easiest gate that you can make would be something like this. Just have those two LEDs wedged in, boom, you got an ant detector, let an ant walk through. With these big LEDs, they're not that sensitive like I was saying from the sides, so that's not gonna work. So one LED on each side would probably be more sensitive, but also these big LEDs still aren't that sensitive each other. So if we still have time, the next goal will be, let's do the same thing, but let's solder some SMD LEDs on. So that's your next challenge, is let's get all ant-sized and tiny. So you're gonna get some of these SMD LEDs, and your goal is to put them on like a little proto board. Do you have little proto boards like this?
Yeah.
Yeah.
Perfect. So you're gonna put it on one of those. It's helpful if you have some kind of like clamp or something, maybe even a very thin strip of tape that can hold it so it sits there right in place. But you can try to freehand it as well. And the only other thing to think about while you are making this SMD LED is your SMD LED should have a marking on one side. So if you look at them very closely, you'll see, for instance, mine have a little green. They have green on one side of their pins. You see that? So take out your LEDs, and they should have a marking on one side. So one thing you can do when you're soldering the LEDs to a board like this, is what I did is I put my LED between two of these holes, and then I soldered it to those two holes, and then I put one hole to each side. I put a wire through, coming through the back. So you see, I gave it the SMD LEDs between two of these holes, and the other wires, they go like an extra hole over just to give it some space. And so you can also solder those wires first if it's easier for you, and then put the SMD LED in the middle, whatever works better for you.
Can I just use the wire, or I need the board?
You can try to just use the wire, sure. Yeah. It'll be even fancier.
Yeah.
I soldered my first one. It's super ugly, but I think it will work.
Yay! Good job.
Okay.
Plug it into your Arduino that has the other one going.
Okay. I
And
will
see if
solder another one.
it lights up. Okay, sure. What you could do is you could figure out which is the positive side and the negative side by plugging one wire into ground and one wire into 3.3 volts on your Arduino.
Okay.
Nice! Oh, that's awesome.
Oh my God! It took us what? An hour and a half?
Not bad. You all took a lot shorter with what I thought would be the long part, which was soldering those LEDs on. And I'm impressed you managed to just solder them straight to the wires too. That makes it even easier. You can make it even smaller. You can put the LEDs everywhere. So that's, yeah, you jumped like pro levels up. Awesome. So then we can actually make it more sensitive by adding more LEDs. So with you all have Arduino Unos, you can do up to 6 Arduino Unos by using the next sketch that I have. So it's like called like Workshop Sketch 3. So your next step and the kind of the final step will be just move on to this, solder up at least 6 LEDs, and then you're going to plug them in, and I'll show you how to plug them in when you're ready with that. And then you'll be able to have, you can pretty much have 3 LEDs on each side, and they're all lighting up something very fast. And whenever you put something in between it, it'll get all these differences from all the angles that the lights are at, and it should be able to pick it up very well. Okay, so then, if you look in the code, the second 2 lines in the code, they say, they have a list of numbers, and one says sensor pins, and one says charge pins. And right now, it probably says sensor pins A0, A1, A2, A3. And then it says charge pins 12, 11, 10, 9, 8, or whatever. So that's just the order of different pairs of pins. So what you could do right now is just use those 2 LEDs and plug one of the sensor pins into A0 and the other across your Arduino into pin 12. And then the next one, you could...
Made it too short. No, it goes, it fits in. So, regardless of which one is positive, which one is negative?
No. So the negative one should go in where the sensor pins. So the negative one should be in A0. That's a big hand.
Yeah, like she wants to get out.
Yeah, and she'll die now.
No.
She doesn't have to die.
Dasza. Impulsam da sztukę zaczynałem jest podany punkt miejsc.
I think she will not want to go inside of this.
She will. No, maybe she'll go to the outside.
Do we have sugar?
Czekaj, Mr. Pigman.
No.
Yeah. Yeah.
No.
Really? So put it like here. You open the cereal plotter, the cereal thingy.
There it goes.
Those.
Oh my God.
Those.
Yeah.
She won't die.
I mean, she just stopped moving.
Okay, then we'll move her. We can
Oh
move her.
no. Okay.
Yeah.
Nothing is working.
Did it detect her? Nice.
Okay, she's still alive. Okay, that's good. That's good.
Yeah, they aren't that easy to kill. They'll be fine.
A couple of times more. Isto si naredila, ne bo našla koloniji.
Did she get loose?
Yeah. Well, we set her free, but
Oh, good.
away from her colony, so
I'm gonna put her back.
She's doomed.
No, she's getting home to her mother and sisters.
Were you able to sense it?
I don't think so.
Not yet.
But we'll troubleshoot tomorrow along with this.
Yeah.
Try or no? Or do you want to eat her again?
No.
No?
No.
Use her free?
Yeah, we set
Okay.
her free.
She says bye-bye. Bye-bye.
Bye. Thanks for joining our workshop, Ann.